Alright, what's up guys? In this video, I'm going to pick up some calculus here, and we're going to integrate a power series in this example. So we're just asked to evaluate this indefinite integral as a power series. So they give us like f of t here. You got the indefinite integral of ln of 1 over t divided by t dt. Okay, so integrating a power series is not hard. It looks a little hard to do the first time you see it, but with some practice, that's what anything in math, it gets better. When you're integrating a power series, you're really using basically two, well, maybe three rules, and they're typically going to be the sum and difference rule for integration and the power rule. So when you're integrating a power series, you're not using any U substitution or by parts or anything like that. There's nothing that crazy going on, so it's actually not that bad. And the only thing you really need to know to do it is you need to know the power series representation for certain types of functions, and then once you have that, it's pretty straightforward after that. So in this particular case, we need the power series for ln of 1 minus t all over t. Well, I don't know what that is, but what I do know is that I do know the power series for minus ln of 1 minus t, and the power series for that is just t plus t squared over 2 plus t cubed over 3, and so on. So that's what I do know. Oh, let me write down the t is going to be in between -1 and +1. Didn't want to leave that off. So since I know that, since I know the power series representation for minus ln of 1 minus t, well, I can easily figure out what the power series representation for ln of 1 minus t all over t is. So if that's the case, then that means that ln of 1 minus t all divided by t, if we want to get a representation for that, and just to kind of show you how it works, I'm going to pull out a 1 over t, and notice how this is positive, this was negative ln of 1 minus t, and you can see our values here for the power series are positive. Well, since we have a positive ln of 1 minus t all over t, then that means the values in here are going to be negative. So it'll be 1 over t, and then I'll have minus t squared over 2 minus t cubed over 3 minus t to the 4th over 4, and so on. Now, let's go ahead and distribute in this t. So if I distribute in this t, well, we'll get ln of 1 minus t all over t. And if we distribute it in, it'd be -1 minus t over 2 minus t squared over 3 minus t to the 3rd over 4, and you would basically keep going. Okay. And so based on what we got here, we can go ahead and basically use the power rule at this point to integrate the power series. Okay, so let's go ahead and do that. So we're going to integrate ln of 1 minus t all over t with respect to t. So really all we're integrating is this. So we're just integrating using the power rule, -1 minus t over 2 plus, or excuse me, not plus, but minus t squared over 3 minus t cubed over 4, and so on. That's all we're doing. And all we have to do for that is just use the power rule. Okay. Now, even though we're integrating a power series, let me just quickly remind you of what the power rule is for integrals. And that's pretty much all we're going to be using. So remember, if I have some integral x raised to the n dx, well, if I want to evaluate that using the power rule, then it's just going to be x raised to the n plus 1 all over n plus 1. But you do have to remember the restriction on this formula that n cannot be equal to -1, because then we'll have division by 0, which we know we can't have. So let's just go ahead and use the power rule here. So if we use the power rule here and integrate this, looks like we'll get -t minus, looks like we're going to get t squared over 4 minus t cubed over 9, and then minus t to the 4th over 16. And we would basically keep going. Okay. And plus c. Now what's odd about what we integrated here, when we go to write this using our sigma notation, what's odd about, I don't know if it's odd, but what's kind of crazy and something you're going to have to get used to, is that when we go and write our final answer by writing it down using our sigma notation, the constant of integration actually comes before the summation sign in our answer. When I first started learning power series, I'm like, that is kind of weird. It's not behind, it's actually going to be in front. So we'll go ahead and write our answer down here, and we'll be done. So let me get another sheet here. Okay. So all we did there was just use the power rule. So our final answer for this, and if you want to, you can just leave it like that. That's perfectly acceptable, but you can write it using your sigma notation. So if you want to write that again, you can. So it'd just be -t minus t squared over 4 minus t cubed over 9 minus t to the 4th over 16. And like I said, if you want to write that as using our sigma notation, this would just be c minus our series from k is equal to 1 to infinity, and it'll be t raised to the k all over k squared. That's how you integrate the power series. So as you can see here, we really didn't use any crazy integration techniques to obtain our answer. Just some basic rules for integration is all we used here to get our answer. All right. So I hope that made sense. Reach out to me if you got any questions about it further. We can talk about it. So I'll see you next time.